Hi, we're PreVENTion, and we are an Arduino-based carbon monoxide safety system. I'm Catherine Lee.
And I'm Mia Solomon. So the issue that we decided to tackle is carbon monoxide poisoning. Carbon monoxide is a deadly gas, which has no odor and no color, making it difficult to tell when it's present. It's very fast acting and can cause very fatal symptoms.
So basically the problem with the current solutions to carbon monoxide poisoning today are that they all need human input, which is really subject to error. The current solution is to have a carbon monoxide sensor for when levels get really high, which is greater than 220 parts per million. And then after that, people should evacuate after they hear the buzzer go off and the alarm and just try to clear circulation in their homes. But the problem with this is that sometimes people might not hear the alarm or can't respond fast enough, causing like the symptoms of carbon monoxide to set in, meaning that like every second that is needed could be lost. So basically the problem is that there's no automatic systems on the market that are fail safe, and we really wanted to create something that could respond to these high levels immediately. Why do we want to tackle carbon monoxide? Because we really wanted to create a product that simplified people's everyday lives, and we thought safety was a big aspect of it. And we chose carbon monoxide because it's been a large problem in the US, and it's just something that has a widespread effect on a lot of communities and our health. So introducing our project, PreVENTion. So PreVENTion aims to eliminate the human input needed to clear carbon monoxide out of a home or environment with an automatic ventilation system that triggers as soon as levels get high. So basically this increases the safety and efficiency of a home by eliminating the human response needed, and just gives everyone a better peace of mind knowing that the gas situation is being handled.
So here we come on our solutions that we generated. So the first solution was sound activated. So it depended on the sound of the alarm to trigger the ventilation system. We decided that this would not be the best solution as there are a lot of variables, which in turn makes it less reliable. So our second solution was to modify an already existing carbon monoxide detector where the chemical reaction would trigger the sensor along with the fan or the ventilation system. However, we decided that this was also not the best solution as it was kind of complicated. So we decided to use Arduino parts instead to do the same thing that our previous solution did. This was a lot more simple and easier to implement on our final design. So how does the actual design work? So the sensor contains sulfuric acid, which when coming into contact with carbon monoxide, completes a circuit and turning the buzzer on. So the buzzer depends on the sensor. Our product will implement a fan, which simulates a ventilation system. So this will be switched on when the circuit is completed. So like the buzzer, the fan depends on the sensor. And the fan will automatically turn on when the circuit is closed. And then once the air is ventilated again and the levels drop below 220 parts per million again, the buzzer and the fan will go off.
So in terms of testing and refinement, we really wanted to understand the Arduino parts we were using. So we used a sensor, which is an MQ7, a carbon monoxide sensor, a buzzer, which was an active buzzer, a fan and its motor, which were a 5-volt. We really wanted to make sure all of these worked individually before we put them together to depend and work in tandem. And we really want to have the buzzer and fan elements depend on the sensor so that they all work as fast as possible. So the first step to getting this to work was just getting the buzzer and the alarm to work. Right here, you see us testing and seeing how that works. So this was our code for that. And once we got that to work, we really wanted to make sure that this sensor and the buzzer could talk to each other and work. So here you see that the sensor, when the sensor levels were high, the buzzer would go silent. And this is our code for that. Next up, we really want to get the fan and the motor to work because this is essential for getting the ventilation system. Right here, you see the fan and the motor are spinning with our code. This is the code for that. And the biggest step from here out is just combining and testing it. So right here, we have the sensor, buzzer, and fan all working together. We tested it in a real life scenario with a car because cars produce a lot of carbon monoxide. Right here, when the levels get high from the car emissions, you see the fan and the buzzer going off and spinning really high. And as we pull it away, you see that the buzzer continues to buzz when the levels are high, but then as the levels start to drop slowly, you see that the buzzer will soon start to stop, right? And then the fan will continue to keep going for those 5 seconds after to ensure the safety. They both stop when everything goes back to normal. And this was our final project code for that. So yeah, our final solution worked really well because our buzzer and fan both depend on the sensor. And when they reach the dangerous level of over 220 parts per million, the buzzer and fan automatically turned on and kept ventilating the system going. So next step, if for future modifications, if more time allowed, we would really want to create a function that would just take the carbon monoxide out of the air altogether. And this would just make our project more wide scope and take care of the issue altogether.
So what's the potential market for our product? Basically, this is any place that a carbon monoxide detector will be present. So a lot of households, any enclosed spaces, they would benefit from our product. Why co-prevention? Why is our invention helpful? It promotes safety. So if someone does not hear the alarm, they will be unaware that they are in danger. However, with our product, it will make the environment of the room safer, as it will not rely on the consumer to hear the actual alarm. It's also efficient, as our product will help filter the air and automatically turn off when it is no longer needed.
We hope that you'll consider our project co-prevention as we increase the safety of toxic gases and their effects in homes. Thank you so much. Have a great day.